This week on In Real Time, 4 orgo students were assigned to make a video explaining E1 dehydration.
What else were you guys thinking?
Like in terms of science or like
Just anything.
Well, we did come up with a.
Yeah.
It's called In Real Time.
I love it.
If you end up in part of our footage, is that okay?
Yeah, that's fine.
Okay.
Great.
That's all we
And
have to
that
do.
part of, what are you secretly filming me? Or?
Oh yeah, right now.
Yvonne, what do you think about your fellow group members?
It's good. All the people are nice.
And what are your thoughts and feelings about E1 dehydration?
It's complicated. It's not the hardest one, so I'm happy about that.
How do you feel about your fellow group members?
You know, they're okay. Like, it's a little bit tough, like, working with Jack. Yvonne is amazing, but, like, everyone knows that. You know, Grace is great. Sometimes, I mean, like, her positive attitude is, like, it really keeps me going for the most part. Sometimes, though, like, if I know that I'm not good at something, Grace would be like, you're great. And I'm like, I'm just not.
What are your thoughts and feelings about E1 dehydration?
E1 dehydration, like, I'm a fan. So how do you feel about your group mates?
I feel pretty good about them. Lily she brings a lot of energy. Sometimes we get off track, I'm not gonna lie. And then Jack is an interesting character. He doesn't really say that much and he says that he doesn't have an opinion, but everybody knows that he's like in there judging.
Don't crap out me.
Jack, go away, Jack! This is a one-on-one! You can't do that!
It's like, see, like he's always secretly judging, even if he says he doesn't have an opinion. Also, I have T against Jack because he's an android, which is really messing up our group chat. And then Yvonne is such a cute bean. Jack, how do you feel about your fellow group members?
Well, Lily doesn't know how to shut up. I mean, I know she likes Belky, but like, you just gotta calm down sometimes. Grace, sometimes she's a little too nice though. I like people who are a little too mean.
What about Yvonne?
She's fine, no problem with her.
How do you feel about E1 dehydration?
I mean, it's easy.
Jack and Yvonne, we're in a timeout. How do you feel about how this reaction went?
So my group members are the most scatterbrained individuals I've ever met. Why can't they just focus on the reaction? How hard is it? It goes like this, and then it pops off, and there's a double blind. It's not hard to do. Just do it!
Wait, there's a question too, Jack in the back?
What do you want now? I need to angrily leave. That's how this works.
Bye!
Yvonne, what are you thinking now about your group mates?
Okay. I'm a little scared about Jack in the back. He is so angry in the interview. Yeah. But it's fine. He explained very well about our mechanism, so it's fine.
Hi, and welcome to E1 dehydration. In a synthesis, you would use this reaction when you need to get rid of an alcohol and you want a double bond. Your reagent for this, if you wanted a predict the product question, would be to put it in acid. H2SO4, benzene, heat, and Dean star trap, as seen over here.
So while our compound in the acid solution, the lone pair in the oxygen will attack the hydrogen. So it will form the H2O plus, and it's a good living group. It's water. And while the protonation happens, the bond will leave. So this part will leave. It's why it's called the dehydration.
So once the water leaves, that will leave us with a carbocation on the alpha carbon. Now a base comes in, and the base attacks a hydrogen on one of the beta carbons. And the electrons in this bond will now move over and form a double bond between these two carbons, which will get rid of the carbocation and will give us our alkene product. The mechanism I showed you is how we get our major product, and now Jack will tell you the difference between our major and minor product, because there are two products formed.
So, why does it form this product? Well, let's go to alkene stability. Boy, we're over here now. Alright, so you want your alkene to be the most substituted. That is a tri-substituted alkene, because there are three things attached to it. You also want your alkene to be trans. That's this one right here. Cis, that's not so good. And more importantly, you want conjugation. You want all your p orbitals closer to each other. So you can see this one, they're further away from each other. We don't want that. That's bad. We want this one, they're close to each other. That's good.